Okay, last part of chapter 13. I know, you guys, it's a long one. I'm sorry. But this has no more problems. Colligative properties and solution concentrations we've done, but now we're done. What we're going to talk about is other types of mixtures, okay? Solutions are well-mixed mixtures, and they're the ones we've talked about so far. And they're the ones that have the concentrations and the rules and stuff. But you have other types of mixtures. One is called a colloid. A colloid is where the particles are a little bit bigger, so it doesn't mix quite as well. In a solution, can't see any particles. It dissolves, and it dissolves well, it mixes well. But a colloid, what happens is the particles are bigger, so they stay in suspension, but because the particles are bigger, you can have some issues. Like I said, the particles, the other type of mixture is called a suspension. So you have three different types of mixtures. You have a suspension, that's the biggest particles. You have a colloid, where they're medium size, and then you have the solution where they're really small. Okay, in a suspension, they'll settle out. It would be like one of those snow globes when you shake them, the little particles always, the particles are that big. But in a colloid, they don't settle out, but they still, because they're larger, they have some properties. You can see some down here, like aerosols are considered colloids. Fog. See, the particles are big enough to reflect light. If you think about it, when you're driving in fog, what happens? You turn your eyes on, you turn them off right away because that's too much, because it reflects the light back in your eyes and you can't see. Smoke is an example of a colloid. Whipped cream, milk is actually, paint. You have these are different types of things that they're a mixture, but you can see the particles are big enough to cause some change in their properties, okay? So colloids are the dividing line between solutions to suspension. So this is the smallest particles, this is the largest particles, and colloids are the ones in between, okay? There's an easy way to tell, because sometimes you can't tell by looking at a colloid if it has bigger particles. You do something called the Tyndall effect. So here's a light going through. If you can see the light as it passes through, that's a colloid. If you can't, it's a solution, okay? The solution particles are too small, and they don't reflect light enough, so you can't see them. But in a colloid, you can. So there's a really easy way to tell if something is a solution or a colloid. Pass light through it. Another example of a colloid that I didn't say is Jello. You can't really see the particles, but they are big enough to cause issues. And that's, again, called the Tyndall effect. If you can see light as it passes through it, it's a colloid, okay? The glass on the right, this one holds a colloid. This one is a solution. So that's an easy way to tell. If you're not sure by looking at it if it's a colloid or a solution, take a flashlight. If you can see the light when it goes through it, that's a colloid, okay? We have a lot of colloids in what they call biomolecules. Biomolecules are the molecules inside of us. There's 4 of them, and they're basically responsible for life, okay? In some molecules, you have what they call hydrophilic. They like water, one end, and then the other end might be hydrophobic. It's afraid of water. And they situate themselves according to these. And again, those make up these colloids. They'll be in a water solution, but they're going to situate themselves so that they're not near the various ends, okay? Large molecules that form colloids in water tend to be hydrophilic. They like water, okay? And usually they have the outward portions facing toward the water, because, they're here. You can see a negative end here of water, or this big molecule, okay? So hydrophilic tend to be polar molecules, and again, they're colloids because this particle, if you dissolved it in a solution, you would still have some effects because they wouldn't be too small. The particles would be larger, okay? Colloids help by what they call absorption. You get ions that stick to them, okay? Ions that adhere into the surface, like you can see right here. Here's a hydrophobic particle. The water doesn't want to go near it because hydrophobic means it's afraid of water, okay? And they'll push each other apart. So this can happen in an aqueous solution, in a water solution, but they'll situate themselves in a way that they don't have to be exposed to much water, okay? And again, this happens in our body all the time. We have colloids that aid in what they call emulsification. To break down our fats and oils, we have to emulsify them. And again, that's colloids that do that. They'll be in a water, they're aqueous, but there's other particles in there that make them colloids and help do that. Here's a fat right here. You can see it has a hydrophilic end, it has a hydrophobic end. So the water is going to be more attracted over here. And again, these just help when they say emulsified fat, basically what they're doing is they're adding stuff to it so we can kind of break it down. Okay, we'd like to have lots. If you're like me, you want to have lots more emulsifiers because you really kind of have a lot of fat to break down, if you know what I mean. Okay, and that's it. So we're done. Again, that part of it was just the end of solutions. Okay, so you get an idea of what we have when we talk about mixtures. And again, remember, mixtures a physical. It's adding a solute to a solvent. If they mix up really well and they have little tiny particles, it's a solution. If they have medium-sized particles, that's a colloid. And if you have large particles that settle out, that's a suspension. And that's your three types of mixtures. But solutions, when we're talking about colligative properties and we're talking about concentrations, we're just talking about solutions. But I just put these in the end. So we've had a lot in this chapter, I know. The next part of the next part, I won't have an assignment with colloids and suspensions and so on. There's going to be the first Labster assignment. So that'll be your next thing you do after this. So we are done with chapter 13.